So seriously, when I walked in the building tonight, I'm like, I have no idea where my classroom is. I've only been in this building once, and that was 2 weeks ago. And I'm like, I remember it's on the 3rd floor, and I'm walking around. It's like, well, it's probably not like, the bassoon studio, and it's not like the film room. It's not like where they develop camera and stuff. So this is Java, right? Good, okay. I recognize a couple of faces like, yeah, you guys look like computer science students, so I'll teach you something. Hi, long time no see. I know that, not having class last week was really weird, wasn't it? I hope everybody had a good Independence Day, and it looks like most people got their assignments in and stuff. I think where I'd like to start is with like Prime Minister's questions. So what can I tell you? What are some of the things that maybe you're still wondering about, or maybe you had some learnings where you'd like to explore that a little bit more? Let's start with your questions, and then we'll dive into my content. So, yes?
So for Project 2, we have all these new classes that we have to implement. Are we just supposed to create new files like you do for the phone bill, or do we need to like somehow download those from your...
Right. So the question is, for those of you listening in at home, is, okay, Project 2, if you look at the Project 2 assignment, it's like, great, you need to create something called a text dumper and a text parser, and it's a Project 2 main. Do you create a new archetype? How do you do that? Nope, you create classes there in your existing project. I recommend you just add more stuff to your project. And all of the interfaces that you'll need, like phone bill dumper and phone bill parser, those should already be there on your class path. They're in the same jar file as abstract phone bill and abstract phone call. So yep, just add a couple more classes to your project. Yeah, most things should just work fine. If they don't, speak up. Okay. Yes?
Since you do the final file, how are you going to test?
Okay. So I didn't tell you what the file format is, right? Part of the assignment is coming up with a file format that you can write to and read from. How am I going to test it? So the file format is text, so that it's at least got characters that you can recognize. I think a couple people asked about, oh, hey, can I use object serialization, right? Because you look ahead, maybe you saw the serializable interface, went off, explored that, and said, oh, wow, this is awesome. It's so easy. Java has this way of turning an object into an array of bytes, a stream of bytes, and then reading it back again. 2-line implementations. Like, nope, that doesn't work because I want a text dumper. I want it to be, first of all, a format of that you design and that you choose. So you can't can't just dump out a byte array. You have to have something that's mildly readable. Here's the guidance I'm going to give to the graders. So as you can imagine, some of the test cases will be along the lines of, okay, create a new phone bill with this phone call in it. Okay, then add a phone call to that same phone bill. And in each one of those, I'll dump out what was written to the text file. And if more stuff is written to the text file, that's probably a pretty good indication that another phone bill was added. So for Project 2, you're right. There's no way to inspect in a human-readable format the phone bill. The graders are going to use their best judgment, and I've never had a problem with anybody's text file format being so difficult to interpret that the graders have said, oh, you didn't really add a phone bill there. It's more lines in your text file. They'll figure it out. Also, because it's text, I can do things like twiddle stuff in the text file. So definitely make sure that your program handles a bogus text file well, because that will be one of the test cases. What else about Project 2 are people wondering about? Yes?
If you're given a file name that doesn't exist, and the instructions say to make a new phone bill and add the command line phone call to it, do you then create a new file and write that phone bill to it?
So the question is, okay, if the phone bill doesn't exist, what do I do? And many years ago, I had some students whose projects threw an error when the phone bill doesn't exist. And I said, this is clearly wrong. How do you create a phone call? How do you create a phone bill? And they're like, oh yeah, right. So yes, if your phone bill doesn't exist, then if the file doesn't exist, you create a new phone bill, add the phone call to it, and dump it out. Yep. As opposed to when it does exist, you read what's there. That will give you a phone bill. You add the new phone call to that, and then write the whole thing back out again. Yep.
So I guess 2-part question. So if they want to load it from a text file, and we have command line arguments to create a new phone call, we first load in the original phone call, add the new phone call to that,
Mhm.
and say if the print argument is invoked, we only print the new one.
Yes. Okay. So the general process is, if text file is there. Step one: read in the file. That's okay. Add the new phone call to it, and then write it back out again. And if dash print is there, do exactly what you did in project one, which was to print the newly added call, and only that. So print doesn't print everything. That's project 3. Print just prints the same thing. Same thing it does in project 1. And again, yeah.
So you said that
This is Prime Minister's questions. You guys started with the right honorable gentleman from the. Anyway, sorry. I'm neither right nor honorable.
if we have
I
a
caffeinated though.
bogus argument in our text file and it's not usable, do we need to deal with that error-wise, or do we just now write over or treat it like it didn't exist? I guess is the question. Or do we
I
just
think
fix it?
one of the things in terms of graceful error handling is if there's a problem with the file, you should issue an error, right? I think that's what you would want in the real world. Is you want to know that there's something wrong, that your file is corrupted, and not trying to be too smart about it because you'll probably outsmart the customer, the user. Good. Yes, in the back. The approximate timeline. So for feedback on your projects. So I was talking with the graders about it, and I said there were a number of you who have struggled to sort of get off the ground, and so then yes, technically the assignment is due tonight, but because some of you just like at office hours got IntelliJ working and everything like that, I said to the graders, okay. I'll have them start grading on Friday evening, and I said please have them done by Sunday afternoon or Sunday evening, and so hopefully by Monday you should have the feedback, and then that starts the clock on the resubmit. So you've got a week after that to fix any bugs and resubmit. But yes, you probably pointed out your project 2 is highly dependent on your project 1. So if you mess something up in project 1, it's probably still messed up in project 2. So let's see here. I've got questions for you if you don't have any more questions for me. Okay. Now I just forgot what I was going to ask. Well, how did the screencasts work for last week? Did you watch them? Okay, and so then obviously you're learning about Project 2 and stuff. Hopefully that was okay. Yep.
I thought it was great. If I just followed, especially how to set up the projects, name projects, I just followed verbatim what you said. I had to stop it a little fast.
I do talk fast, yeah.
But just follow that verbatim.
Okay, good. So hopefully I provided what you needed and that you were able to understand what I was telling you. Okay, good. What else did I talk about last week? Oh, I remember what I was going to say. So what have your experiences been like writing automated tests? So I saw a couple questions about I've seen stuff with the integration test, which I was glad that you guys are working with that or you were experimenting with it. But what have you learned? What have you experienced in writing automated tests for your code? Yes. No, that's a very astute observation. It's I spent as much time writing the tests as I did writing the code. Do you feel that? So when you were doing either test-driven development or writing unit tests, the part of the time writing the code, do you feel that you spent, if you hadn't written the tests, do you think it would be the same amount of time as just writing the code, or the same amount of time as writing both, or somewhere in the middle, somewhere more? How do you think that compares to not doing tests?
I think for this one, it would be the same, but I think for increasing complexity of work and doing the tests at the same time, reduce the amount of time.
Okay. So probably, so higher startup costs to get you going and stuff, but you're hopeful that then will return dividends in the future as you've got a suite of tests that you can rerun. Yeah.
Found it hard to follow the method a lot of the times. So I, for example, could write a code to see whether a date was valid, or so I used regular expressions
Yep.
to test that. So it's you fix one thing, every other test you wrote after that was just going to pass because you did your regular expression right.
Yeah.
So a lot of it just felt pointless. It was why am I doing this? I know it's going to pass, but I'm doing it just to check the block, kind of.
Well, that's a good point, right? So when especially with the input validation, you might have like, oh, here are like 10 different things I want to validate, but shoot, once you get the validation working for one case, they all pass. So what would you do differently now that you know that? Would you not write those other test cases?
I mean, in theory, they're important because if anybody, like, if I'm not the project owner anymore and somebody changes what I did with that regular expression, it could theoretically break something else. So they're still good to have.
So you sort of still got the safety net there, but you know it didn't really inform your implementation very much. No, fair enough. Yeah.
So I wrapped a bunch of integration tests around my project one.
Mm.
Did a refactor into project two. And it really nice to have all those tests there to kind of validate that my refactor was correct.
Yeah. Cool. So yeah, so he did a bunch of integration tests, testing his command line for project one, and then when he started project two, all of those tests were still valid, and that's kind of on purpose, right? So it's like because the command line doesn't change very much for project two, I guess project two functionality is just really a superset of project one, and so then you can reuse that.
Are we going to get into mocking objects?
Oh, are we going to get into mocking? There's content on that. Is it in the JUnit screencast? No, I think it's in the dependency injection screencast. I go into that quite a bit. Actually, let me. It's been so long. So, dependency injection is a design pattern that helps decouple your code. This is whatever, week 5, week 6. So it's a little bit more advanced where you're at this week. But I do encourage you to review this stuff because it can really help you break your code up into nicely independent testable units and make sure that all the units, all of the classes, work independently of each other, and so then you have to do less testing with them involved. Oh yeah, here I go. I talk about testing mock objects. So there is content later in the course. I do when we talk about the project 4, when we talk about REST API and the servlets and stuff like that. I think I do have a couple of examples of using this Mockito API to mock out parts of your web interaction, so you don't actually have to be running a web server in order to execute this code. So yeah, we'll touch on that a little bit. It's kind of an advanced topic, and but it's something that I think will really help you out as your code gets more complex. Yeah.
So I guess I had some confusion still about the difference between the actual unit tests and integration tests.
Mm-hmm.
To me, I probably did it wrong, but what I did was very similar.
So for project 1 and 2 and 3, there isn't much difference between the integration test and the unit test when you really think about it, especially sort of practically. Conceptually speaking, there are differences. So I mean, conceptually, a unit test really is just one unit. So you're dealing with one class or maybe the class and the things it interacts with. So it really is very isolated. The integration tests conceptually are end-to-end tests. You are, when you think about your project, yep, there's the internal guts of your project, like your phone bill class or your text parser class, and you can unit test those independently. But when it comes to your integration test, you're dealing with your main, and that is end-to-end. And actually, in project 2, it's like your main and also files. So there are more things, there are more pieces involved. Now, practically speaking, for these unit tests and integration tests, you're using the same tools: Java code and JUnit and stuff like that. And yeah, the little integration test framework that I wrote. Again, when we start seeing the web project in project 4, and then the Google Web Toolkit project in project 5, you'll see that there the integration tests are larger in scale. So it's like in project 4 in the web project. Pardon me. In project 4, the web project. The integration tests actually start up a web server, and then your test will hit that web server and interact with it, and then validate the output there. That's a much bigger, heavyweight process than it is just running your main program inside a Java VM and handling the system.exit nicely. So yeah, there's more to come on that, and I think over the course of the class, you'll get a better appreciation for some of the distinctions between unit tests and integration tests.
I have a question on 1.
Yeah.
Project 1. So if you want to include a reference, or excuse me, a package, just from like the not the standard library, but I'm trying to add
A third-party package, right?
No, the command line. I don't know.
Yeah.
I'm having some. I don't know if anybody else. I don't know what anybody else is fine, but I'm still in the configuration.
So, okay, are you saying, hey, listen, out there, there are libraries out there that'll do command line parsing for
Yeah,
it. Why do I have to write it myself?
Yeah, and
Is that it?
Yeah, no, we can do that, right?
No, you can't.
Oh,
It's part of the assignment. So, yeah,
Okay, glad I
in this,
wasn't able-
yeah, no, it's, yeah. So, yes, in the real world, you wouldn't write your own command line parsing. I mean, it's year 2018. I get that. I understand. It's also part of the class. Projects 1, 2, and 3 are actually part of Project 4 too. Is all about doing command line parsing. It'll be old hat by the time Project 4 comes around. Then you'll be able to focus in on your web API stuff. So no, in general, actually not in general, you can't add third-party dependencies to your code. Some of that is because it's kind of challenging. As you saw, you got to know a lot about Maven, things like that. It's also one of the reasons why I don't let you I don't let you submit your POM file, because you can put all sorts of other stuff in there, and I want to download it. So not the most real-world experience, but part of Project 1 is actually most of Project 1 is parsing the command line.
So we shouldn't include any other packages in our home, or unless you tell us it's okay.
By packages, do you mean like hey, the GNU command line parsing library, or do you mean like other things in the JDK, like a Java util class? So Java util, anything that comes with a JDK, yeah, go ahead and use that. But things that aren't part of the JDK or the other libraries that it depends on, which I guess mainly my library for Project 1.
So is there a command line parser in the JDK?
I don't know. I don't think so. I'm probably not in Java 10. They've done.
You wouldn't want us to use it if there was, right?
You could use it, hey, as long as again, as long as it works. I'm not gonna look at your code. But I'm not aware of one. Yeah.
That's probably why I couldn't include it.
That's good. Okay. Anything else? Okay. Oh yeah. Yep.
Can we open a window or something?
Yeah, I've got this one open. Now it's kind of windy, and so people are by the window. If it's like messing up your hair or whatever, you have to make a call. But yeah, it's getting super stuffy in here. So cool. Yeah, there's not air conditioning in this building, is there? Okay. It's a fine arts building, right? They're starving artists, and so it's like you should probably get used to being uncomfortable in the summer. I don't know. I'm sure they're nice people. Anyway, that is not this week. Okay, so in terms of the content of the course, in weeks 1 and 2, it was all about sort of getting the foundation in place. So Project 1, yes, you had to write the little command line program, but it was really about getting your tools working, making sure your environment was working, making sure you got IntelliJ and Maven, and you can build on your favorite local machine, and you can also get things to work on the CS department's machines. Things are starting to get more interesting with Project 2. You're actually able to do something with your phone bill. And you're learning more about the Java APIs. So I hope you got a chance to explore the collection classes and some of that stuff for Project 2. And then in Project 3, which we'll talk about tonight, it's more about using the facilities for working with dates and stuff like that. So, like we've been talking about, this summer's offering of the course is a little unusual and challenging. First of all, because we didn't have class last week. Hopefully we've gotten through that. But there's another component of this course that I'm really struggling with, and that's the following. For the last 3 or 4 years, pair programming and mob programming have been part of the course. And it's something that I was able to offer because we were in a facility that was conducive to it. I don't know how it's going to work in this classroom. You guys with your desks with their own tables and stuff, I don't know how easily you can huddle around a laptop. I want to try it tonight, and we'll gather some feedback, and we'll see how it goes. Maybe we can have a good learning experience, but maybe otherwise I'll have to do something else. So I think the way I'm going to approach tonight is the following. There was a video about pair programming that we didn't watch last week. We'll watch that now. We'll also learn about coding katas and the coding dojo. Because what I'd like to do is, as a class, do some coding and give you an opportunity to explore more about test-driven development and working with others on what I call these code katas. And then the rest of the class, and then something that I'll do after the first break is talk about Project 3 and what that means. Okay? So, let's watch some videos. Do I have volume? Oops. Oh, I'm muted because... How'd this work last week? Does anybody remember what I had to do to get this to work? Oh, I had to... Sound. Internal speed. Okay, there. I'm on that. I'm turned up all the way. Such device has no output controls. Oh. I should have had this working beforehand. Sorry about that. I go to headphone. Gotta pause the recording while I figure this out. Okay. Full screen it. Here we go.
Hello and welcome to Fun with Pair Programming, an introduction to pair programming for students. If you're a student who is new to pair programming, you've come to the right place. This video will help provide valuable information to make you the best pair programmer you can possibly be in your classes and beyond. Pair programming refers to the practice whereby two programmers work side by side on one computer, collaborating on the same design, algorithm, code, or test. The pair is made up of a driver, who actively types at the computer or records a design, and a navigator, who watches the work of the driver and identifies problems, asks clarifying questions, and makes suggestions. Switch roles from time to time to share the work evenly and get the most out of your pair programming experience. You'll hear effective pairs constantly chatting as they jointly decide how to tackle the task at hand.
Well, actually, I don't even know where it's saving this stuff. So we create a new patient and it adds a record. Oh,
Alright.
probably in save data file. Mm-hmm. So it's going through, looks like a list of records.
Mm-hmm. So we probably, since we just added the height and weight, I don't know if that's actually getting written.
Yeah, probably not.
Okay.
So
Why do so many thousands of students around the world prefer pair programming? Why don't we ask some to compare old-fashioned solo programming to this new and innovative system?
Wait, what was the order?
You would program by yourself, so you'd usually be just by yourself in a computer, maybe in a cube or at a single desk, and it's a very lonely type thing. It can be.
Well, it could be really frustrating. You'd sit there banging your head against the desk and trying to find, the missing bracket, or couldn't figure out why the logic in your program didn't quite work right. And with two people there, it's a lot easier to work those problems out a lot more quickly, so you're not frustrated all the time.
This is nothing new either. Most science labs take advantage of lab partners and small groups. Computer science is no different. You can learn a lot from working with other people. Students find it helps them get better scores on programming projects. Pair programming helps them learn, so they get better grades on exams as well. Mostly, students report that they enjoy getting to know the people in their classes better. This makes it much easier to interact when problems do arise, because you've got a class full of friends instead of strangers. Last, but certainly not least, students are much more likely to figure out solutions if they've got someone to brainstorm with. and this can lead to faster completion times and a better understanding of the subject matter. Students often find the whole experience much more enjoyable and less frustrating. Pair programming will also help you prepare for your career in computer science. In the professional world, people collaborate and pair program all the time, and as an expert, you'll already be ahead of the game. Have you ever spent most of your class time with your hand in the air, getting nowhere on a project while you wait for help from your professor or lab instructor? With pair programming, those days are history, and you'll find yourself having a lot more fun. Who knows? Maybe you'll even look forward to the alarm going off in the morning so you can get to class. Now that you know the basics, let's look at some simple do's and don'ts of pair programming. First, be sure to talk. Not a minute should go by when you're not communicating somehow. Don't say anything that might insult your partner. Even if you're only joking, he or she might take it personally. Don't forget to listen too. Both the driver and the navigator should be fully engaged in the project. So much so that the driver can pass the keyboard to the navigator at any time, and he or she will be ready for the switch with no questions asked.
Periodically switch positions so you can gain experience in both roles.
Switching helps prevent errors and stimulates conversation too. Be patient. Be prepared to explain yourself to your partner, and don't get frustrated if they don't understand it first. By explaining your work to your partner, you'll be helping yourself learn as well. Remember the ancient Chinese proverb, "To teach is to learn." And be sure to give the driver a little time to correct his or her own mistakes. After all, no one likes a backseat driver. Respect your partner. The golden rule is key here. Just remember to treat your partner with the same level of respect that you expect from him or her. It doesn't matter if they are from another culture, an introvert, an extrovert, a procrastinator, or the valedictorian. We are all here to accomplish one thing, and everyone has something to offer. Take breaks. You can get more done in 1 hour pair programming than in several hours by yourself. But this can take a toll on your brain. Don't forget to take a break every so often to keep yourself fresh and energetic. When you return, you'll likely see something you overlooked before. Be prepared. Be sure to do any preliminary work ahead of time, and don't be late for appointments with your partner. Their time is valuable, as is yours. Hygiene. Think about it. How would you feel if the person you were going to spend a couple of hours with smelled terrible? Take a shower, brush your teeth, bring some mints. You know the drill. Have fun! Working with someone else can be a lot more fun than working by yourself. You can share a laugh, relieve some tension, and have someone to celebrate with when you get that last test case to pass. Believe me, that's a great feeling. Now that we've gone through all the things you should do as a pair programmer, let's go through some of the things you should avoid when working with your partner. Don't be a keyboard hog, or think that just because your partner is a novice and you're more experienced, that they won't bring something to the table. Don't constantly tell other people what to do either. You don't want to be the only person in the class that no one wants to work with because you're too bossy. There is another side to that coin, so don't be intimidated. Some people are afraid that they don't know enough, but chances are your partner feels the same way, and you both know way more than you give yourself credit for. Trust me, it will all be fine. The primary goal of pairing is to work together towards the best possible solution, so don't be afraid to speak up if you disagree with your partner from time to time. Your partner may as well be working alone if you're not willing to speak up. If you're unhappy with your pair programming situation for any reason, don't hesitate to talk to your professor or teaching aide. That's their job, and they will be happy to help you resolve whatever problem you may have. As you can see, there are many benefits to pair programming, but there are also a few speed bumps. Sometimes you'll find it difficult to find time in your schedules to meet, for example. But students all over the world agree that the benefits outweigh any drawbacks that they can find.
If there's two of you working on it, typically you're spending a lot less time working on it, so this is great for homework. Then also I would say that in general, your solution is going to be better.
So if you're working with somebody and their grade or their deadline matters to you, you're more likely to get your work done at an earlier time. Also with pair programming, you can typically have higher grades on assignments. There's higher quality code as well.
This concludes our journey through the exciting world of pair programming, but there's still much to learn. Take these tips with you into your next pair programming lab and join the growing number of pair programmers across the country, the world, and beyond.
Well, it doesn't get any less cheesy with time, I have to admit, but I think it sort of drives some of the points home. So, how many of you have heard of pair programming before? Something that, okay, everybody's raising their hand, right? Have you done any of it? Anybody? Yeah, a couple people? Like what in the context? Here at school, at work, at home, at a conference, where?
For project here, well, I did
Yeah.
mod programming.
Oh, mob programming? Cool.
Like 3 or 4 of us.
Yeah, yeah.
It was just group projects.
Yep. Okay, so tell me about your experiences, pair programming or mob programming, and sort of like, did the things they were saying ring true, or the things that they might have missed or called out? Or,
It's pretty happy.
it's pretty accurate, yeah. Yeah, good for knowledge transfer, right? So when you've got, maybe someone that's more familiar with a topic or, a coding library or whatever, and then can help transfer that knowledge. Good, good, good. So what I'd like to do tonight is sort of work towards pair programming, but first let's introduce the project that we'll be working on. Anybody who has studied a martial art has gone through something called a kata. The whole idea is that it's a small learning exercise. And there are a series of what are called code katas that people have written in many different languages. They're usually small little programming projects that are meant to be done in like an evening, a couple hours at the most, and they're to help you practice the art of coding. And so take a small, understandable problem and work it out. Maybe these are good ways to approach a new programming language, or maybe a new programming platform. So there are katas around, hey, your first Android program, or your first, AWS data storage thing, or whatever. This is a little introductory article that you can read on your own. I think for tonight, I want to start with this simple kata about scoring a game of tennis. And here's how I'd like to go about it. I'd like each of you to take, let's say, 7 minutes and read over this page sort of by yourself in silence. And if you don't have a laptop or whatever, you can either read it up here or look over somebody's shoulder as you're writing. So first, let's take a few minutes to read on our own. And then also on your own, I'd like you to think about, when you take some notes on your computer or sketch something out, how you might go about implementing it. Both how the implementation looks, but probably more importantly, what are some of the tests that you would write to implement this kata. So let's take 7 or 10 minutes to do that. I'm going to pause the recording.
But yeah, you want I don't know if that's, I don't remember. My favorite volleyball. But they were like, you served to me, and I liked it up. I'm not okay. Yeah. Okay. So, alright. Okay. Now, don't worry, more talking will happen soon. Now I'd like you to find another pair. In a group of 4, talk about your ideas for the kata. So find another pair and talk about what test cases that you think are necessary, and then also the classes that you would use to implement. And go. Okay. Really? Yeah, I don't know, but 2 objects carrying around. Well, you can do operations on those 2, and score difference or something, or
like basically Carlos stuff, like player up that what's on the player.
Yeah.
Yeah. You just have player one, player two, and then my.
Yeah, that would be the only reason why you want to have it. Yeah, different. Besides the score, there were other Yeah. Well, you get functions that we have player one player and this one. It just would be four. Yeah, sometimes it's or your constructor with a
Is there a winner function? Essentially, basically, just have
or above.
basically like when somebody scored, check the score as a winner.
Yeah.
Okay, so let's come back to the big group. So you've had some time to think about the kata by yourself and work on it by yourself, work with a partner, get some ideas, and then you shared with a group of 4 your ideas. So now let's have everybody share their ideas, and here's what I want to do. I'm going to go to each group of 4 and tell me a test case that you that you'd want to implement in your in your kata. So how about you guys start right here? So given when then. When you have some certain game of tennis, when something happens, then what do I expect to have to occur?
If a player has at least 4 points,
Mm-hmm.
and the difference between the 2 scores is 2 or greater.
And the difference between the 2 scores is is what? Greater than 2?
2 or greater.
Is 2 or greater? Then
There's a winner.
okay. Okay. So that's like this is like we said player 1, and then player 1, and then player 1 is the winner. Cool. I'm going to adjust the margins on this so we have a little bit more space.
If it was greater than 2, you throw a exception. If it's 4, though. If it's
Oh, is there another scenario that happens when a player one has at least 4 points that you want to call out? So you're saying there's something else. There's player.
I was just saying if there would be a problem if one player had at least 4, and the difference was greater than 2. One player more than 4.
And player 2 has more than 4. Then an error should be issued?
No.
Okay.
What I think he's saying is if player 1 gets more than 4 points and the difference is greater than 2, then that shouldn't happen. That's an error. And we're 4 points we're saying.
Yeah. And the difference is greater than 2. Then an error should be issued. Yeah. Nice. Okay. We'll come back to you guys in a little bit. Let's go to this group of four.
So you
Sorry.
take off or greater at the first one.
So it's 2. Okay. Next group.
If one player has the advantage and the other player scores a point, given that player 1 has the advantage, when player 2 scores a point, then player 1 no longer has the advantage.
Nice. Oh, it has the advantage, and that means the score is deuce. Did I spell that right? No. There you go. Has an advantage. Okay. Nice. Next group of 4. A test case that you'd want to validate to make sure that your code's doing the right thing.
How about a boring one? There's no real given, but when the game begins, both players are allowed.
Good. The game exists. Your game, exists. Well, I guess sort of like, a game exists when the game starts. The game starts. Both players have a score of love. Okay. Who's ever next? Who's got I don't know where the boundaries lie. Who else has a test case? Actually, I like where this is starting. It's sort of like the first play. So like, okay, the game exists, the game starts, no one's got anything. Like, what's the next move after that? So next group, what would be like the next player? Okay, go back, yeah. Okay. Let's see here. So the game exists, player 1 scores, then? Yes. So a new game has started. Player 1 scores. Player 1 has 15 points. Score of 15. Okay. 15. I think I call out player 2 has a score of 0. Okay. Another scenario? Okay. Under what conditions?
Under what conditions after player 1 has scored?
Okay. So then player 1 has a score of 15. Like that? Yep. Okay. When player 2 scores, then what happens? Okay. Sorry, can you say it again, please? Okay. We're sort of seeing the pattern here, so I don't know how much more we need to dig into this. What are some of the more interesting conditions? We called them out up here, sort of at the beginning. What else? Yes? Got that up here. Is there a different when, though? Maybe there's a different scenario. Okay. Okay. There is a deuce. Yep. Okay, if either player scores. That player has the advantage. Okay.
I feel like the bang could be one of them winning, so that would be sharpening up. Someone can have the advantage. Yeah. When they're at things, when there is a things.
Is there? I thought there was.
But for them to eventually win, if one of them has the advantage, that is, right?
It's just like the player 1 has the advantage, and player 1 scores a point, and then.
Okay. There you go. Cool. I'll add another insert row below. So yeah, when player 1 has the advantage and player 1 scores a point, what happens? Player 1 wins. Cool.
What about having something like making sure that the game is ended? I don't know what comes next. Game reset, like the
Okay. When a so the given that the game has been won by a player, so then when what? They shake hands across the net. One throws their racket. I don't know. Do tennis players do that anymore? I haven't watched tennis since like John McEnroe back in the 90s. No, do they? Okay, do they? Wow. Okay. Angry men, and maybe women too. I don't know. Okay. What other scenarios are kind of interesting? Things that are maybe noodling around in the back of your minds, like, oh, what would happen in this scenario? Yeah.
Player 1 has 40 points.
Okay.
Player 2 has less than 30, and player 1
It's fewer. Oh, is this 4 supposed to be 40?
So
We kind of just
we were operating on this premise because tennis has this complicated. It's not complicated. It's just not code friendly. Where it's 0, 15, like different scores. Is that you can do a mapping and just do 0, 1, 2, 3, 4, and then you just
Liberated.
and yeah, you're just comparing, and then when you're doing your
You keep incrementing past 4 for all the juices and advantages.
So when you're calling out your test case, this is good, right? And I think this is kind of a lesson that we're learning here. So it's like this team, when they were talking about the game and how it's implemented and the language they use like 0, 1, 2, 3, and 4. Other people were using a different language, and when you saw a test case, it was like, well, what does that mean? So I don't know if there's necessarily a right or wrong in this situation, but one of the things that when you're writing your test cases, you need to be thinking about the language that you're using and how you're communicating, the terminology. Okay, let's. So in this play is 4. How does that translate into this other language of like a score of 15 or something like that? Okay. Right. So I think it's when they have.
30, oh, you're right. Score 3.
So okay. So is it at least 30 points, or they have 30, or exactly?
Well, for how we were thinking, it would be at least 40.
Okay. It's 40. Okay.
And the 2 scores is essentially 2 scores. So player 2 would have 0 to 15.
Okay.
That test case now says if a player has 40 points and is 2 ahead, then they are the winner, and that's not true.
You have to score after 40.
So it's like player has at least 40 points. She can't have more than 40 points, right?
Right.
Okay.
That's 40 points and scores.
Has 4 points. Well, and is that the same here?
So what that
No.
shows is player 1 has 40 points.
Yep.
Player 1 scores and has player 2 has some. So I guess it's a given position.
Yep.
Player 2 has 15.
Okay. So when player 1
I got 30. So 30 or fewer.
30 or fewer, yeah.
When player 1 scores, player 1 wins.
Okay.
That's the
Cool. Okay. Any other test cases that you want to call out?
Player 1 has 40, player 2 has 30 scores.
Ah, okay. I like that. So when player 1 has, so I did the same thing there. So player, oops. Oh, I think that was that. Okay. And player 2 has fewer than 30. When player 2 scores, the game goes to deuce.
You would want to say player 2 has 30.
Sorry?
You would want to say player 2 has 30, not has fewer.
Ah, good point. Yes, has 30. Player 2 scores, the game goes to deuce. Okay. So these are some test cases, and this is good brainstorming that we've done, and we've got a good idea of it. Okay, how might we go about implementing it? What are some of the concepts that we need to model? And maybe sort of like how would we model them in code? Go over. Which team hasn't had a chance to talk yet? See what I did there? Yeah, old teacher trick. Yep.
We said we would make like a match class to
Okay, and like, what are some of the methods that you might put on that class? What? Yeah, okay. Check the score for a winner, or just report the score, or is this?
Yeah. I think I get score and check.
Get score of the game, okay, and then you know, is there a winner or get winner? I don't know. Okay. What are some other ideas people had for as far as how the code might be structured?
If you're really bored, I guess you could have a player class object.
Why would only a bored person create a player class?
Kind of
So
unnecessary.
with like because it's using Wii Tennis as the premise here, it doesn't care. I mean, it doesn't. All of this object's going to do is have a number that's going to increase essentially.
Mhm.
So if I'm creating it in a class, now I've got to worry about setters and getters and doing all this other stuff I don't need to do. Whereas if I just had a game class that had an int player 1 and int player 2, that is much easier to manipulate and less possible issues.
Okay. Nope, there's no operator overloading.
Like, get the diff between two player objects.
No. Anyway, yeah. So no. Well, you actually, get the diff. I mean, you can have a player object, and you can have a method which is like, show me, diff the score with regards to the other player. You could do that, I guess. All depends on where you want to put your logic. That'll be up to you guys. Okay. Any other design things that people want to call out? Any good ideas that they had?
If we want one player to be a little bit better than the other player, we could have a player object and just wait there.
Oh, okay, that's advanced. You're taking the AI class, aren't you? You're just like, I've already implemented it's about to take over the world of tennis. Okay. It's growing a mullet. I haven't watched tennis in a long time. Okay.
I think you need a method to have a player score.
Okay, so yeah, some method to represent a player scoring. Okay. We just have a numeric field. Okay. Cool. Okay. So, excellent. I think we've brainstormed some good test cases. We've had some discussion about what our implementation might look like. Let's take a break, and when we come back, we'll do some coding. I created a project for you guys to clone if you want, and we'll do a little bit of coding. So let's take 15 and come back at 7 o'clock.